Yes, you can start whenever you want.
Okay, great. Shall I share my screen?
Yeah, if you want, it will be.
I think the best thing for me to do is kind of just give people like a little bit of just a navigation around the website and just
Mhm.
okay, all right.
Sure.
Let me just get it loaded up. Okay, so okay, so can you see the screen?
Yes. Yes.
All right. Okay, so my cohort 2 project proposal was to build a zk app directory and eco zk app directory and ecosystem hub kind of thing, just place basically where people could find out information on all the teams building on Mina, and also the zk apps. Obviously, as they come into mainnet and everything, there's going to be a lot more. So was the initial proposal was just kind of to catalog the ones that had been done already in various hackathons and builders programs, things like that. Okay, so so yeah, it's kind of a traditional website. So we've got like, it's very basic, very simple navigation. So we've got like an ecosystem directory. So we've got all these teams building stuff with Mina. So you've got wallet staking providers, blah blah blah. So I'm just going to click that as an example, and that will give you this will give you a breakdown of the different kinds of things. So okay, so if you went to RO Wallet, you get a page like this. Actually, if you log in, you can log in. You can create a user and log in, and you can have an account. Oh, that's the back end. Okay, so if you've got you can register an account. You have a little your own profile page, and so this is kind of like your home page as a user. So you can do. The idea is to keep we'll keep this up to date and different things. So there's a competition at the moment to win some Mina stuff. So you can enter the competition, all this kind of stuff. So the idea is to try and keep it up to date, keep it fresh. It's really easy navigation, so you can see all the different apps are separated by different categories. You know, so it's fairly easy to navigate. What I also did was because I built the website minacrypto.com, so I kind of created an archive of all the articles that were on there. There's something like 500 of them, I think. So they've all been transferred onto this. So you've got like a kind of a time capsule, I guess, of all the old blog posts that were on the old website, and they all come back to here. So this is kind of a separate section. And let me just think about what else we've got on here. So you can find, you know, if you're looking for something from a particular program, say the zkIgnite, you can see all the zkIgnite funded program, all the funded projects on there. And what we've also done is Not all of them have got it yet, but a lot of the zk apps have actually got translations in Hindi and Turkish. Tala and Rakesh has been helping me do the translation. So the idea is trying to make this as global as possible, and to just to try and make it as accessible to everybody. Obviously, not everybody speaks English. You can also like these things. So as we get more apps, and obviously it comes to mainnet, we can kind of create this popularity system where apps that are well used and liked by the community can be upvoted. A part of the original proposal was also to create a team zk, basically people who could help developers with testing out apps in the future. So that's one thing that's kind of set up. We've got a couple of hundred people who are actually signed up to actually actively help developers. So this is the kind of thing that in the future will be more relevant, and you know, this is something that will build over time. We've actually got over 1,300 people who've registered for the website since it launched. I think it launched just before Christmas in a couple of weeks. There's 119 zk apps on there at the moment in total, and there's 50 ecosystem members entries on there. So there's quite a lot of stuff on here. This is showing everything because I'm an admin. Normally it would just show, and yeah, I mean, that's kind of the basic overview of it, really. I just click into a couple of these just to show you different lines. This has got Hindi translation. I've still got to add about 50 Turkish translations on some of the apps, so that's still something I've got to do. That was kind of part of the extra, what would you call the extra part of the grant to do that. So yeah, I kind of guess that's it, really. I don't know if anybody has any questions. I'm quite pleased with how it's gone. I think that there's lots of things that could potentially be added to it in the future. I would really like to integrate a wallet and kind of build up the community that way. I've also been talking to the guys at Social Cap about us working together on different collaborations and giving, you know, trying to grow the whole ecosystem in general. Like I say, I'm not running a kind of staking providing service or doing any external things, you know, that on the side for Mina. So the idea is to stay impartial and to promote everybody without worrying about, you know, any particular external financial situation. So the grant's been really good, actually, in that way. It's kept to keep it kind of independent. So yeah, that's about it, I guess.
Yeah, perfect. Thanks. Yeah, thanks, Pete, for all the things that you have been doing for the community, and, you know, taking care of us. Yeah, I wonder if there are any questions from the crowd. If not,
I have a question.
sure, Laurie.
So how do you see this website being used? Like, who uses it in, like, what for? And when does someone, like, find it, and where do they find it, and what is it, like, mainly used for?
Well, obviously it's quite new at the moment. We've got a lot. There is a lot of content on there, and it's starting to rank quite well for zk, Mina things. A lot of developers have used it actually to kind of use, because on each of the zk apps there's always links to the GitHub pages, so it's kind of useful as a reference point. Obviously things develop and upgrade as they go, but a lot of developers have been looking at the apps and kind of looking at if they're doing something similar. It's kind of a starting point, reference point for people. So it's good on the developer side. From the community side, I think it's good to just give them this reassurance that there's stuff going on and it's kind of easy to find in one place. Obviously, like, you know, in the future, the community as it will be using zk apps on mainnet and have some kind of meaningful interaction with these apps. So I think as time goes by, that will become more a relevant situation. You know, and there is, I'm actually going to do a proposal for the next zkIgnite to try and expand things a bit. And one of the things I was thinking was just to create kind of a GitHub thing where people can update their zk apps or their ecosystem directories, you know, with in a kind of in a secure way. So it's you know, it can be their responsibility. Also, kind of like a news section, I think would be good. It's all a question of just time management, really. It's just Mina's getting to that point now where there's so much going on. It's kind of hard to keep track of everything going. You know, there's new stuff popping up all the time. So I think the challenge with a thing like this is keeping it up to date and keeping it, you know, keeping it relevant and current and. Yeah, but it can only grow, I think. So it's you know, there's people using it every day, and like I say, we've got like a competition on there at the moment to win like a Mina ledger. So it's trying to stimulate the community as well, keep them interested. I hope that answers your question. You've got the thumbs up there. So yeah, so you know, like I say, what would be great for me with you guys as well as I know, because a lot of your building stuff is to try and have this good communication with you. So like, you know, it's one thing building something, but the big part of it is raising awareness and for people to actually know that it's there. So if you can keep me you know, keep me up to date, and like I say, if I implement this GitHub thing, then we can keep things fresh. There's nothing worse than going to look at like an archive of an old website that's, you know, that's all completely out of date. So I think that's key is for people to use it and people to you know, if they're building an app, it's the first thing they do is I've got to make sure people know about this. So that's where you can help me, I guess. And that's it.
All right. Thanks, Pete. Then I think we can continue with Mikhail, Mina authentication.
Okay. Hi, can you hear me?
Yes, I hear you a bit like
Low.
yeah. No, it was low. Now it's better.
Okay, I'll try to maybe make it a little bit louder.
Yeah, please.
Is it better now?
Yeah, it's a lot better right now. A lot better right now.
Okay, great. Let me show my screen.
Yeah, we see it. Perfect.
Okay, great. So yeah, a little bit of introduction, and then I will do a presentation of the demo project that uses Mina to present the data flow that you will like have to support if you want to use it. Sorry. So Mina is basically a set of TypeScript packages that has a like modular and plugin based architecture. to help integrate zero knowledge proof based authentication and authorization to like standard Web 2 services. It is a library that has an integration with Express.js and Passport.js for the zero knowledge part. It uses Mina's 01.js, obviously. And it includes some, let's call it, official plugins that were implemented as a part of the system. One of which is I will present it later, an Ethereum NFT token time lock login. During the presentation, I will be using some like notions that will mean a very particular thing. So as I mentioned, the library is built around the concept of a plugin, and a plugin is like a piece that implements and introduces this new way of authentication. So it's this is the part that has the proof creation logic and proof verification logic inside of it, and it is actually divided into two parts. One is used by the prover, which in our case will be browser client, and the other part is the plugin, so the same name, and it is it configures the plugin and verifies the proofs.
Sorry, Mikhail, can you make it bigger or full screen or something?
Okay, I will try to make it bigger.
Yeah, much better. Thanks.
Sure. Yeah. On the right, there is, let's say, a dependency graph, like simplistic, and so there are some components, and all of them you use the library, which is like a standalone package. Yeah, there is something called plugin server, and this is like an optional tool that aggregates the functionality around working, configuring, and interacting with plugins. And yeah, there is a proof, which is basically a wrapped O1.js proof. So this is quite similar. This is how you would structure your usual like system using Mina. So there is a server, some kind of API, or like any kind of HTTP service, or even different kind of service but you should, in order to do it, you will have to like tinker a bit. But Express.js based HTTP servers are like out of the box supported, and there is a client, and they use the corresponding parts of plugins. And this is how we set up the demonstration part of the project. Any questions so far? Okay. So as I mentioned, there are like 3 implemented plugins, but unfortunately, due to a bug that I don't think is fixed yet, we cannot compile recursive zk programs in browser. I think it used to work, but now it doesn't. Hopefully, it will be fixed soon. So I will only be able to present 2 plugins. They will like generate outputs that then will be used to create JW tokens. So a very common way to authenticate HTTP requests. And the demo is structured so that we can see the data flowing around during the process. The system is quite modular, so sorry. It should be do not disturb, but yeah, but for example, you will not have to use the plugin server at all. We only need a slight modification to the Mina strategy component of the system. Okay, so let me show you the demo. So once you clone the repository, you have a demo server and demo client component, and then after like very simple, I'm sorry for that. Okay, let's proceed. So yeah, so there is the server part, and it has a configuration which you can copy from a template configuration. It configures 2 plugins. One is the NFT time lock plugin. The other is the very simple demonstrational plugin, which I'll show in a moment. And once you have the config in place, you can run all the backend services with a prepared npm script. So in order to use the NFT time lock plugin, currently this configuration uses a local development blockchain, so that it's like instant and easy to develop with. So what you saw was a boot up of the Ethereum development the chain environment. And it always starts from beginning, so we have to fund an account that we will use and mint some NFTs using scripts that are available with the project. Okay, it should be done now. And now I will start the client. Okay, so this is the demo UI. Let's select a plugin. So we have 2 loaded. we don't yet use web workers to compile the provers in the background thread, so it blocks the UI. It's quite fast. And for demonstration purposes, we have so let me tell you about the plugin. So the simple preimage plugin is like very simple plugin that works pretty much like a standard password authentication. So the server receives like a hash, and we've approved that you know the preimage of the hash, and then it if this hash matches the hash in like the simple mapping, you will get a role assigned and get the authentication token. So yeah, let's authenticate as an admin. I know the secret password. Here you can see the data that comes from the plugins, the provers form. Let's generate the proof. And it generated the proof along with all the data that we'll be submitting to the server, which is basically the proof and the public input, the hash in this case. So let's submit it. It works quite fast. The proof was checked for validity. It was valid, and we get the token. And with this token, we can validate requests to protected resources. So normally, you will not be able to access this protected route. Yeah, so we have this proof, right? And this proof, because of for example, this mapping can be changed by an admin, or in this case, the validity of the existing proofs may change. So plugins also have to support the like possible revocation of outdated proofs, and this is also implemented. So if I was an admin and changed the credential needed to become admin, or like you can imagine a different kind of setup where it is assigned to like a more granular scopes of access level. But in this case, let's say that I have changed the oops. Oh yeah, because it was the same hash, so it deleted the mapping. Okay, this should be it. Yeah, so I have changed the password. So and the proof that we used should no longer be valid. I should not be able to access the data and to be able to refresh my token. And yeah, that's the case. We cannot refresh it anymore, and we cannot access the data anymore. We would have to generate another proof and re-authenticate. So this is like the basic and the usual flow you will find using Mina. let's now proceed to a little bit more involved plugin, which is the NFT time lock plugin. And this is a little bit different because it the server keeps track of a set of locked NFTs, like NFTs locked in a particular contract, which is a part of configuration. And once you lock NFT, you for now you do it with a hash commitment. And so you with NFT you like register into a set of allowed members, and then you can within this set you can prove your membership in this set without revealing your identity. So let's test if it works. So I have minted 2 NFTs called 1 and 2. So let's look 1 along with a commitment. So the problem with sometimes because I'm using the development chain, the wallets can get out of sync. Oh no, it might work. Okay, let me try again. In such case, why is it? Sorry, it hasn't happened before. It's like very slow. So sometimes you have to refresh the wallet. It will not be happening when interacting with with a real blockchain, right? Because it doesn't get reset every time I start the server. I think this should work now. So first we have to allow the NFT transfer. And then there is transaction that will lock the token. And once the token is locked, the server will rescan the available commitments, and we should be able to pick one of them and to prove that we know the image. This is totally unexpected because it was working. I have made a slight change on the front end to show these plugin is compiling overlays, and maybe just before the demo, and maybe I have changed something. Sorry, let me reload the front end. Let's wait a moment until the server will grab the commitment, and let's try again. Okay, the prover is not compiled for some reason. I don't know if if we have time to for me to fix it, and we'll try to fix it. It was working very similarly to the other plugin. I might have just broken it to make the presentation more beautiful. It just looks like the plugin is not being compiled. The compilation is not being called for some reason. So this one works okay. So I don't think I will be able to present this plugin right now. But I can tell what should be happening. So let me go back and maybe try it for the last time. So normally we would expect the usual the usual flow. So all the commitments are fetched. We provide a proof that we so something caused the prover not to be compiling. We would expect this to build the proof quite similarly to the other plugins. Sorry. Then we would submit it to get the tokens, and we would be able to access the protected resource. So this is the standard flow. It is not plugin dependent. Here, similarly, the underlying source of verifiable data, so the public input to the proof, which is the Merkle root and the Merkle tree, may change over time. So plugin does support the revocation similarly. So if we unlocked the token, or anyone else would unlock their token and change the set of available commitments and the Merkle root, then all the people that already have authentication token, they would have to recreate and resubmit the proofs. So yeah, unfortunately, I was not able to demonstrate it. I may do it, record it, and do it later, or I don't know.
Yeah, please, when you have a chance to correct it, like you can send a recording as soon as possible.
Okay, sure. So yeah. Oh, it disappeared. There are some already planned development. We have Mina Navigators grants, and with those grants, the development and maintenance, the Mina will be ongoing. Will keep ongoing, and we have some ideas for further development, such as using newly introduced ECDCA signatures instead of hash commitments. So you will not have to come up with those passwords. Your secret key will just sign some data and use it as instead of it. For example, in this NFT timelock plugin. Also, we may introduce the location proof powered by zk Locus. That was, I believe, I think it is one of the recently delivered Mina's projects. It will be nice to see how they interoperate. And for now, the passport strategy is quite simple, but it doesn't have to be. So we intend to expand on it a little bit and provide things such as plugin combinators, where you could take any 2 or more plugins and combine them. So, for example, in addition to prove that you are in some area, you will also have to lock the NFT, and only then you would get the authentication to access some resource. And also the UIs for provers will be easier and more streamlined. So you will not have to like re-implement every time you build a plugin. It will be like semi-automatic by using just a schema. And yeah, that's it. Apologize for the technical issues. And thanks. Do you have any questions?
Yeah, awesome. So Mario has some comments. Yeah, thanks again. So if you can solve the issue and send a recording, that will be the best.
Okay, sure. I will do it and contact you on Discord.
Okay. Thank you.
Great.
Awesome.
Thanks.
So right now, thanks again and
Just
congratulations.
I would like to add that the demo that was sent as a part of the submission already has a demo demonstrating
So
demonstrating that it's working, just with a more uglier UI.
okay, so in the submission form, you submitted the demo that is working, so we can electors can have a look at this one then, right? Okay.
Exactly. Yeah, we can send the updated version, but for time being, the functionality is recorded, and it's on the demo that was provided. We'll just like update it as with the new UI, which it's just like aesthetics as soon as possible.
All right, thanks. So then, thanks again, and let's continue with Charlie.
Yeah, hi. Can you hear me?
Yes, we hear you.
Okay, perfect. Let me share my screen.
we see your screen.
Okay, cool. So let's start. Okay, I'm Charlie, and I'll be presenting Warhome, the auditable social media platform. So some of the issues this project tries to solve are, for example, that users don't know why they see the content they see. And because of this, users can make conscious decisions about what configurations to choose or about how to behave in a platform. So they can personalize the content they see according to their true interests. So another issue is that users don't know how moderation works. So moderation systems can hide their unfairness and arbitrarities behind a black box and never improve or be accountable. And on top of this, users don't own their accounts. So this can get shut down by those obscure and arbitrary moderation systems. And this can be very damaging because a person's super network can be disrupted. Also, people can lose valuable data and connections. And in general, this hurts freedom of speech and the ability of people to coordinate in a fair and neutral environment. Also, all of this is very detrimental for collective intelligence and creativity. So we can make better decisions as a society and to live better lives as free people. Also, we would like to have more open and reliable APIs that behave more like protocols. So users and developers don't need to worry about potential breaking changes due to future changes in the ownership of the platform or corporate policies, business decisions, etc. So we would like to provide more guarantees to users and developers and creating a more composable digital landscape. So we could and should try to improve legacy Web2 platforms through better legislation, auditing, and accountability, but this is very challenging because, for example, even if they open source their code, there's no way to guarantee that the code they release matches the code running on their servers, or to verify to what extent humans intervene arbitrarily. Also, access to their APIs and data is expensive and restrictive. They can find ways to trick audits, and the cost of permanently monitoring these platforms is prohibitive. So we need a better alternative, and a solution is to build open, auditable, and accountable platforms by default. So here's a high-level diagram of the platform I've been building. And the basic idea is that users sign the actions they do on the platform. So they own their digital identity since they own their keys to their account, while every action in the platform is authenticated through signed messages by users. So for example, if a user wants to publish a post, the user signs a hash derived from the content of their post. Then this goes to the server that uses the signed message as the input to a zk program that will guarantee that the state of the platform is updated by following the established rules encoded in the zk program. Then the zk program produces a proof that can be used to update the state of the platform to include the new post. So the state of the platform is composed by on-chain and off-chain state. Or on-chain state lives in the Mina blockchain and can be seen as the root of the whole state of our platform. And this state is updated through proof generated by the zk programs and can be used to verify the off-chain state that the off-chain state is valid. The off-chain state lives in open and decentralized storage platforms like Filecoin. Data should be stored publicly and redundantly. So users have the guarantee that their data and the platform will remain available. Also, well, now when users watch content on the platform, so like here, the server responds with the content and the witnesses associated with each piece of content. So the client uses these to automatically calculate the routes for the state of the platform. And the client also fetches the on-chain state, which compares with the calculated routes to make sure that the data in the server response is valid. So if the data is valid, then we can make further validations, like making sure that no post is being skipped or censored, that posts aren't being artificially boosted, and that in general, we see the exact content we want to see according to our settings. So building on these ideas, we can implement many features like auditable reactions, comments, reposts, moderation, etc. Now let's look at the implementation of some of these ideas. So if we open our client, it will ask for some content from the server. And here by default, our client is requesting for 3 posts, for the last 2 posts, and requesting for the last one repost. So we can customize how many posts or reposts or comments our client does per request. And also we can customize like from which block to which block that represents the time of publishing of each post, comment, reaction, repost, etc. we want. But for now, here we can see the post and repost we requested. So we requested 3 posts and 1 repost. And we can see we are getting post 6, post 5, and post 4. And 1 repost over here, that is repost 2. We also can see like, obviously the author of the post, who reposted this, how many reactions, comments, and reposts each post has, their number for ordering the post globally, which is the number of the posts in the total as total posts, and also the blog in which each post was published, that is here. And when we received this count, we also received the respective witnesses for each piece of content. And our client calculated the routes for the state of the platform, fetched the routes from the blockchain, and compared that they match. So the client didn't indicate any errors. So we can be sure that everything we see here is true. That this post is really post 6. This content was published by this user, has this many reactions, this many posts, this many comments, and so on. So if we open our browser DevTools, we can see the routes our client fetched and calculated. So just for demonstration, I'm here printing the routes that we fetch from the blockchain. So for example, here we fetch the post route, the routes for the post, and also calculated the route derived from each post and their witness, and compared that these were equal. So here we can see fetched post route is this number, calculated post route is the number. We did the same for the reactions of each post, the repost, comments, everything. So we can be sure that everything we see here is true. And for example, since we know that everything is reliable here, for example, we can be sure that no post is being skipped, since we have post 6, post 5, post 4, so no post is missing here. And our client validates this automatically. Same for reactions, comments, and reposts. So to demonstrate how our client will alert us from some post being censored, let's artificially remove a post that we already received from the client. So here we will be simulating receiving a ground response from the server that is missing a post. So if we update our feed, then our client automatically will tell us that there is a gap between post 6 and post 4 here, and the server may be experiencing some issues or censoring posts. So this is the kind of messages we will expect to see when the behavior from the server is not what we will expect. Let's restore to the normal behavior. So also the same will happen if we go to the profile of a user and a post is missing. So for example, if we go to the profile of this user, we can see that here posts are numbered different because here, for example, we have that this is user post 3, while in the global count is post 6. That's because this is to make the validation that no post in the profile of this user is being skipped. So we can validate that we have all the posts in the correct order without skipping anything. And this allows us to make these kind of validations. Something similar happens with comments. So for example, here we go to the comments of this post, and we can see if we open here this again, we fetch the root from the blockchain for comments, calculated the root for this comment, and compared these are equal. So everything is okay. We can be sure that this is comment 1, that this content is not being manipulated. It was posted by this user at this block. And so we can do the same kind of validations. We do something similar for reactions, that no reaction is being skipped, etc. So also we can know with certainty how many posts there are in the platform, how many posts a user has posted, how many reactions, comment, and repost each post has, etc. So if, for example, we request 10 posts from a user and we get less than 10, we can know if that's because that user has posted less than 10 posts or if the server is hiding posts. So this is very important to keep the integrity of our platform. And again, all of this also applies to reactions, comments, and reposts. So if we go to the comments of a post, we make the same kind of validations, etc. Now let's see how users update the state of the platform. So first, a user needs to connect their wallet. So here we are going to connect our wallet. There it is. And once we connect our wallet, this text area is revealed, so we are able to post. And also, we now are able to react, to comment, or to repost any of those posts. And so here, let's create a post from this user, that is a new user. So here we derive a hash from the content of this post. that is represented by this number that this user is going to sign. And once we sign this, this goes to our server. So here is our content, or the hash derived by this content, and this number is equivalent to this hash. Also, we are running our prover that is constantly querying for like pending actions in the platform that it needs to generate proofs for. So here it already found our new post, that is post 7 in general, and is the first post by this user. So for example, the order of this post is being guaranteed by our zk program. Our zk program guarantees that each post increases these counters properly. So we are ordering posts as we will expect, and this can't be tampered. So here it is generating the proof for this. And also, this will happen the same for reactions, for example, if we react to this post. Now we will sign the ID for this post together with the code point for that emoji. And this will go to the server. We'll order our reactions with a global counter, a global that numbers the reactions by that user in general, and a counter that orders the reactions to that specific post by any user. Now it already created the proof and send it to the Mina network, where the transaction is pending. And so the prover waits until the on-chain state is updated to update our off-chain database. So once this transaction confirms here, our prover will know that it confirmed the transaction, and then we'll update our database to so we know that that post has been included successfully, and then our server can automatically pick this from the database, and then is able to include this post and its witnesses in its responses. So, for example, if we right now update our feed, we won't be getting this post yet because it hasn't been confirmed. But once it is confirmed, our server will automatically get that post updated in memory, and then respond with that new post and its proper witness. So using a block explorer, we can see the current root state for our platform that is represented across 4 contracts. So one contract for posts, 1 contract for reactions, 1 contract for comments, and 1 contract for reposts. So we can see here that we have 6 posts in this contract post. And so, for example, our post contract stores 3 values: the global counter for all posts, that is this simple 6. Also, the root of a Merkle map that stores a counter for the posts of each user. So that counter for the posts of each user is stored in a Merkle map. This is the root of that Merkle map. and the root of another Merkle map that stores the state of each post. So that's this root is the root for that Merkle map, storing the state of each post. Similarly, for the other contracts, they just have an extra Merkle map, so represented by this root. And this Merkle map, what represents is, for example, the counter for the reactions to each post. So we can know how many reactions exactly has each post, how many comments and how many reposts. Let's see if we already confirmed. It hasn't confirmed, it's still waiting. But something to mention is that here we are just calculating the proof for one post, but we can parallelize this process. And for example, in the time that it takes to, it already confirmed. In the time that it takes to generate one proof, if we parallelize this, for example, if it takes 2 minutes to generate the proofs for one post, we could take also 2 minutes, just 2 minutes to generate the 1,000 or 100,000 proof, just generating each proof in a different machine. So the platform can scale. So it already confirmed our post, and it picked our reaction that we already reacted to that post, and it's created now the proof for that reaction. And here we can see that our server picked these 7 posts automatically when it got confirmed. So if we go to our client and update our feed, we should get now the new post here that is also audited, etc. And we one key thing of this project is that users are able to customize what they see. So far, for example, they can request more posts. We know that we have 7 posts, so we can ask more posts. And we can also indicate a time frame from the post we want to see. So we now got more posts. And for example, we could limit or the posts we see to just the posts that are before before this block. And also our client validates all of this. So there are no posts before this block. So we are not getting any posts. We are just seeing the one repost here that is valid because it is between these blocks. And for example, we know that we have those 2 reposts. So now we have here 2 reposts. And the idea is to add more features, like users being able to, for example, request just the posts that are above certain number of reactions. For example, have more than 100 reactions, or have more than, I don't know, 20 reactions by the fire emoji, or have more than a certain number of comments or reposts, creating lists of users, etc. So users can fine-tune their experience and be certain that they see the content they want to see and aren't being censored or manipulated by any third parties. And I think that's all for this demo. So hopefully I was able to make you excited about this project. I like it a lot, and I want to keep building on these ideas. So if you have any questions, please feel free to ask.
All right, perfect, Charlie. So I see Ivan has a question. Ivan?
Yeah, sure.
Yeah, so far so good. Thank you for your presentation. Yeah, I have a small question about like what do you think about like from what I get from your presentation is that on each update to the application state you are updating the root inside the smart contract. Is that correct?
Correct.
Yeah, so imagine a situation like with a real social network or with a real active blog. You have like a lot of updates per second. So how would you tackle that? Like obviously you cannot update the root like each time like somebody makes an update. So how would you tackle the asynchronous updates?
Do you mean like the lag that the users will experience? Like, for example, here we needed to wait a few minutes to see the new post that we created. So how to make that user experience faster?
Yeah, this is one of the aspects of the questions I'm asking. But especially like just imagine the situation when like a lot of users simultaneously like using the application, like how would the smart contract tackle that?
Yeah, I mean, for example, let's imagine that we have a lot of users and we have like 10,000 posts in 1 minute published within 1 minute. So when we parallelize our proof generation, we are going to order kind of merkleize the generation of proofs. We are going to parallelize the generation of the 10,000 proofs, and we will be able to create 10,000 proofs, 100,000 proofs, or whatever number of proofs we need within just a few minutes. And then all of that, we, for example, generate 10,000, 10,000 proofs. And then we merge all of those proofs into a single proof. That final proof is what we submit to the blockchain to update the state. So we choose one proof that is the result of merging all those thousands of proof. We can update the state, the on-chain state. So that's the way we are thinking about how we will handle that volume at scale in the platform. Also, regarding the user experience, for example, we could make something like that the user, for example, generates here the post, and maybe the post, the user sees the post here immediately, or whatever action the user does, but maybe that is grayed out or something until it is confirmed. And when it is confirmed, like it gets color, or so we will indicate in a visual way that action was already confirmed. So we have like many ideas to improve the user experience and make it feel almost like any traditional Web2 social media platform. So I don't. I think Mario has a question.
Yeah, great. That makes a lot of sense. Thank you.
Okay, thanks.
Do we have time for a question or?
Yes, sure, we have.
Yeah, you mentioned the parallelization of proofs. That's quite interesting. I probably missed it in the architecture, but how are you doing that? Are you starting from your backend? You are starting a worker for each of the proofs you need to generate? Do you have some workers that are already deployed and you delegate work for them? I am interested in how we are doing that. If you can explain.
I actually have a naive implementation of this, and I wanted to implement it for this demo. but I didn't have enough time to set up like the cloud infrastructure to make the parallelization of the proofs. But basically, the idea is that let's, in a simple example, you get 2 actions on the platform. So you need to generate 2 proofs for that action. So yeah, you just start workers, and each worker lives in its own machine. That's why I didn't leave that implementation for this demo, because I'm just running all of this on my laptop currently. And what was happening is that even though I was parallelizing the proof generation, since the guys at O1JS are really good at their job, the generation of just one proof takes all the available computational power wherever they are machine they are living on. So the time was basically the same. So what I needed is to spin up more machines, and so each worker runs on a different machine, and actually take advantage of the parallelization. So for example, we generate the proofs for each action, in this case 2 proofs, and then we merge those 2 proofs in one single proof, and that's the proof that we submit to the chain. So that's basically the general idea, and I actually was able to implement that. It just wasn't practical for this demo, because I'm running everything in my laptop, so it will take basically the same time.
Okay. So yes, I think this is quite a good solution. I am doing mostly the same in Social Cap. We are parallelizing transactions, and I have a set of defined and fixed set of workers already running, and I have a sequencer that deploys to each of one in turn, such as a round robin. And DFST on the Mina NFT project does something quite similar to that, but he starts Lambda functions in AWS.
Yeah.
And so I think it be quite a good solution for some of the limitations of the time it takes to proving in Mina. Also, we have also detected that proving in Mina in a different node, or in a node and not in the browser, it's much more it's quite faster. So I think what you are doing is quite a good solution. Okay.
Yeah, thanks. Yeah, I think that basically most CK apps will need to do something similar, because I mean that's why I think also matters created product kit, and there are other L2 solutions, but also like in this case, like the architecture of this CK app, every CK app can have their own off-chain logic, and I think that O1JS is very powerful on this, because you can have arbitrary computation off-chain, and then you submit one proof, and I think that's very elegant and powerful by Mina and O1JS. So
very good solution, really. So I think it's the only way of scaling.
Yeah, exactly. That's the way for basically, I think 99%.
Yeah.
So
thank you very much for your feedback.
Yeah, thanks for the question. So I think Larry has another question.
Yeah, I have a question about the deliverables for the project. Is the website part of what you are delivering?
Yeah. Actually, I did everything from scratch. The contracts, the client, the server, everything is done from scratch, and everything is part of the milestones for this project.
So also the website is part of the package.
Well, more than the website, the client. The client. So right now the website isn't online. Like there is not a website. There's a client that is the one I show. This one this is running on my local machine. So this is the client. All the code is also available in the repository. I don't know if that's the question.
Yeah, I'm just wondering because your proposal says that the client will be made available on a website. So what does it really mean?
Oh yeah. I mentioned that on my proposal, but unfortunately I didn't have time to like set up a website on the cloud and a server so people could try it out. But I mean, also the user interface, the user experience. I think that it is not right there to people to start to like having access to the platform, like if it was a service already. So I think that I will do that later.
Okay, thanks.
All right, thanks. It's a very interesting use case and like really raising my hopes for a better world where we audit what people say.
Yeah, me too.
So the problem is like a real, very big problem. And thanks for all the work, Charlie, and the great presentation.
Thanks. So I think that's all. No more questions. So thanks everyone for your time.
Well done. So let's continue with Rafael, and then at the end, Michael can solve the problem, so he can get the demo again. But like, let's continue with Rafael first.
Thank you, Yasin, and good morning, good afternoon, good evening to everyone. I'm gonna share my...
Good reading from my world.
Okay, so okay.
We see your screen.
Can you see my screen?
All good. Yes, we are seeing it.
Okay. So my name is Rafael Campos. I'm based out of San Jose, Costa Rica, and my project is called zkIgnite, which is the zk oracle for Mina powered by TLS Notary. So this is the agenda. First, I'm gonna make a brief review of the proposal. Then I'm gonna explain in very simple terms what TLS Notary is all about, the architecture of my project, and finally a demo. So regarding the original proposal, as some of you already know, I participated in the cohort 1 with a project called Ziponi, which was basically way to verify that someone tweeted something on Twitter. Okay, that's the easiest way to express what it was all about. So the problem with the project was the Oracle part, because I figured out during the project, the development of the project, that I was trusting 100% the Oracle. By the way, the Oracle that I used was the same Oracle that you can find on tutorial number 7 from the Mina docs. It's basically a REST API that retrieves data from an external source like Twitter, and then responds with a JSON object with the data signed by the Oracle. So I figured that I should do something about that and try to develop something that was less trusted. Maybe not 100% trustless, but at least that requires less trust. So that's basically the purpose of zkIgnite. On the right side of the screen, you can see the original architecture for my project, Ziponi, not this one, but the previous one. And the part that is here in this square is basically the Oracle, which I am trying to replace with a better solution. So zkIgnite is that solution to replace the trusted Oracle. So basically the way I do this is by leveraging an open source project called TLS Notary. It's currently supported by the Ethereum Foundation under the Privacy and Scaling Exploration team. So basically, zkIgnite is like a wrapper around TLS Notary, because TLS Notary is kind of difficult to learn how to use, especially because it's written in Rust, and well, Rust is still not a very well-known language, at least for me. So basically, my project what tries to achieve is make it easy for zk developers, zk app developers, to use TLS notary. So I try to abstract away the complexities of dealing with directly with TLS notary. So regarding the milestones, originally I proposed 3 milestones. The first one was to set up TLS notary and try to notarize something. Okay, I did this for a midterm demo in November. I used Discord as an example, so I notarized a Discord direct message. So that's already done. The second milestone has to do with the actual development of the project of the zk Oracle. So what I did was to replace the tutorial 7 Oracle with something that uses TLS notary under the hood. Okay, so that's also done. And finally, documentation. I tried to write a lot of documentation to make it easier for a zk app developer to use my project. So I think I also achieved this milestone. So before I can explain the architecture of my project, I need to explain what TLS notary is and how it works. So I'm gonna spend a few minutes doing that. So first of all, why is TLS notary useful? What is it useful for? So as you all know, TLS is the protocol that allows us to interact with web servers in a secure way. So TLS basically does 2 things. It encrypts data so that no one can sneak on the data that you are retrieving from the web server, and it also signs the data. Okay, so that for example, in this case, the client called Alice is sure that no one modified the data in transit. Okay, so Alice is certain that the data is valid and hasn't been tampered with. Okay, that's what TLS does. The problem is that the data that Alice retrieves, the client retrieves, is not portable. And with portable, what I mean is that Alice cannot send this data to a third party like Bob, and so that Bob can trust that the data wasn't modified. Okay, and this is because TLS uses symmetric encryption and symmetric signing. So Alice and the web server share the signing keys. I mean, the encryption and signing keys. So nothing prevents Alice from modifying the data and then sign it with the signing key. And Bob will not be able to tell if the data was originally sent by the web server or if it was modified by Alice. So that's the reason why TLS cannot solve this problem on its own. Okay, so there's here's where TLS notary comes in and allows the data to be portable. Gives Bob the possibility to trust that the data wasn't modified by Alice. So to understand how this can be possible, we need to understand how TLS notary works under the hood. Okay, so what TLS notary does is basically uses multi-party computation to make it so that the TLS signing keys are never in possession of Alice. I mean, Alice never gets access to that TLS session keys. How? Well, Alice and the TLS notary perform a multi-party computation that allows them to interact with the web server, okay, like a regular TLS session, but the keys are split between Alice and the notary. Okay, so that prevents Alice from modifying the data and signing it. Okay, so here is the whole flow. So now it's not Alice interacting with a web server, it's Alice with the notary interacting with the web server. So the data that is retrieved from the web server can be sent to Bob, and Bob will not need to trust Alice that the data wasn't modified. Okay, so that's how TLS notary works under the hood. However, there are trust assumptions here, some trust assumptions. For example, Bob needs to trust the notary, because if the notary colludes with Alice, then they could potentially modify the data. Okay, so there's a certain level of trust that Bob needs to have in order to accept the data as valid. So there are options to try to minimize this trust assumption. For example, Bob can require that the data be signed by several notaries, independent notaries. And this way, if there are enough notaries, then it's very low, very unlikely that they all colluded with Alice to modify the data. So this is one way to minimize the trust assumptions. The other way is for Bob to be the notary. I mean, he can run the actual notary server, and this way he doesn't need to trust anyone because he is the notary. That's another possibility. Okay, so I don't know if there are any questions regarding TLS notary before I explain how zk notary uses it to create the Oracle application. Okay, I'm gonna continue. Yes, Mario.
Yeah, I forgive my ignorance, but if you later, after you have finished, you can explain some of the features of TLS over SSL, which is another protocol, and why you have chosen or why you're using that. I think it would be quite interesting, at least for me, but I can wait till you finish your presentation. So thank you.
Okay, yeah. I was expecting that. No, don't worry, Mario. Yeah, okay. So TLS is actually the modern version of SSL. So SSL is no longer really used. We use TLS for every interaction between a client, a web client, and a web server. It's the standard right now. It's the modern way to interact with web servers. Whenever you access a web server using HTTPS, you are using TLS. Okay, so that's basically what TLS is for. It's it's a standard that allows data to be encrypted and signed and prevents anyone from being able to access that data in transit. That's basically what TLS is. And I didn't really select TLS because I mean TLS is the only protocol that is currently being used for that. I don't know if that answers your question.
Yes, fully. Thanks.
Okay, yeah, your turn. Okay, so now to the architecture. So I have divided my project into 4 different components. So the first component is called Approver, which is basically the TLS notary server. Okay, so what I did was to wrap a REST API around the TLS server. So the TLS project. So basically what I do is I have a web server running, waiting for connections or calls from outside. And when it receives a call, a REST call, it invokes the Rust code that is part of TLS notary. So it notarizes the data that is requested and then returns a proof, which is the contents of the interaction with a server, with a web server, along with the signature. That's what the prover is. It's like the core of the project. Then I also am including the verifier, which is software written in Rust that verifies that the proof was actually executed. I mean, what was actually created by the notary, and that was signed by the notary. So it checks that the signature is valid and also that data actually was retrieved from the original source. Because it's in Rust, I decided to compile it to WebAssembly, and with that create an npm package, and it's published on the npm registry. So from a zkApp developer point of view, it's just something you include in your JavaScript project or your TypeScript project, and you can use there. You don't need to mess with Rust at all because it's already compiled. It uses WebAssembly. Those, I can say, those are the main two components. The other two are just like utilities. So the parser, as we will see later, basically allows or helps to interpret the output of the verifier, because the verifier is generic. It's not. It doesn't care if the data was retrieved from Twitter or from Facebook or from Reddit. It's generic. It just takes the data from the prover and verifies that it's valid. Okay, and its output is plain text, so it's very hard to parse. So I created this utility sub project called the parser, which has specific code for different origins. For example, if the data is being retrieved from Twitter, then there's a Twitter parser, and it basically parses the plain text and converts that into JSON. That it's more, more structure, and it more easily, it's more easy it's easier for the developer to use. Okay, and finally, I created a script that allows anyone to deploy an instance of the Notary server on AWS. Okay, for development purposes, I was using a server running locally. I just cloned the GitHub repo from TLS Notary and run the server. But if you want to deploy this to production, you need to run the Notary server elsewhere. So this deployment script allows the developer to easily deploy the Notary server on AWS. So here's a step-by-step explanation of how the project works. So step one, Alice calls the REST API from the prover, and I'm going to use Twitter as an example. In this case, she's asking to notarize a tweet. Okay, so she sends the tweet URL inside the GET request to the prover REST API. Okay, so after this, the prover and the Notary server perform the MPC computation, the multi-party computation, and create a joint session with the Twitter server, with the Twitter API, and retrieve that data. I mean, retrieve the tweet that Alice requested. Okay, then the Notary server notarizes that and signs the data, and then the prover returns a JSON object with that inside to Alice. Okay, so this is the equivalent of retrieving data from Twitter directly, but in this case, it's notarized and it's signed by the notary. Okay, so going back to the portability of data, now Alice can take this JSON object and send it to Bob, and Bob can easily verify that JSON object represents an actual tweet and that it's original, it wasn't modified. So how does Bob do that? He basically uses the verifier npm package. It's called zkNotary verifier. It's on npm, and he invokes or calls the verify function, which takes two arguments: the proof that Alice sent to him and the public key from the notary to verify that the signature is valid. Okay, so the output from the verifier is this plain text. Okay, so as I said before, it's kind of hard to parse because it's generic. So so here is when Bob can leverage the parser project, the parser npm package, and call the twitter.parse function, which takes the output from the verifier and outputs a JSON object that has, the actual data from Twitter. Okay, in this case, the part that Bob cares about is the tweet's body, the part that actually represents the tweet text. Okay, so that's the architecture, and now I'm gonna run the demo. Okay, so here is the repository for my project. Here are the 4 components: the AWS script, the parser utility, the prover, which is the heart of the project, and the verifier. Okay, so I'm gonna first run the TLS notary server. Okay, here is the TLS notary server, and then I run it with cargo run. It's a Rust project, so it uses cargo. Now it's running locally on port 7047. Okay, so now that I have the notary server running, I can then run the prover. Okay, so now it's running. Remember, the prover is a REST API. Okay, so now I'm gonna go ahead and use Postman to call the endpoint that is running on the prover. So it's a local host 3000. The endpoint is called notarized Twitter, and the argument or parameter is the tweet URL. Okay, so I'm gonna send. It's sending the request. The request just arrived here on the prover, and we have to wait like 20 seconds, 30 seconds for the notarization to take place. Okay, so here the prover is establishing a connection with the Twitter server, an MPC connection along with the notary. They received the response, and the notarization was performed correctly. So if we go back to Postman, here we have the response. Okay, so it has 2 parts: the notarized session with Twitter, and the proof, which also contains the notarized session inside. Okay, so now remember, we are Alice right now. We are the ones who are invoking the TLS, the prover REST API. So now we take this proof, which is made up of a lot of stuff here, and we send this to Bob. Okay, so now let's see what Bob has to do. So Bob will run the verifier. Remember, the verifier is nothing more than just a npm package. So I here have an example of how to use that npm package. It's called a zk notary verifier. So I import everything from that package. I'm also importing the Twitter parser from zk notary parsers, and here I am reading the proof that I conveniently have here already. It's the exact same thing that we got from the REST API. So and we also read the notary pub, which is the public key from the notary, and we invoke the verify function from the verifier. Okay, along with the 2 parameters. The output result, we parse it using Twitter, and then we log the result. So I'm gonna run this script. I need to go to the examples directory. Index. Okay, so here, what happened here is that the compiled Rust code and WebAssembly code was executed, was run, and this was the result after the parsing. So here we have the request that the client made to the Twitter server. We have the response from the Twitter server with all its headers, and we have the body, which is what we are really interested in, which contains the tweet that we were trying to notarize. Okay, so yeah, this is exactly what we were going after. So if you're Bob and you run this and you trust the notary, you can be certain that no one modified the data and that this is the actual tweet that was retrieved from Twitter. Okay, so I think that's it for the demo. I don't know if you have any questions that I can answer. Yeah, I saw Ilya's hand first, so go ahead.
Hello. Thank you, Rafael. First of all, great presentation. So I was going over the TLS Notary right now, just reading the docs and watching the presentation as you speak. I don't fully understand what advantage TLS Notary provides in terms of security and more in the trustless sense, in the sense that you don't need to trust anyone in comparison to the Oracle. Because at least from what I researched, please correct me if I'm wrong, there isn't anything in that proof that verifies the observation of the computation or of the essentially of the exchange of what the TLS Notary did. Because if that public, let's say you make a request to an AWS server, well, what ensures me that it is in fact running, this specific notary, like the TLS Notary implementation and instant, and it wasn't just men in the middle data just signed with a private key.
Mm-hmm. Okay, so that's the reason why you have to trust the notary. I mean, remember, this is not a complete trustless environment. You need to trust the notary. You need to trust that the notary is running correctly, the execution is done correctly, and then that the notary is not colluding with anyone. So basically what we did here is we shift the trust from the original Oracle that was just some code running somewhere to a notary server that is also running somewhere, but at least we know, or we might know, that notary is trustworthy. Okay, so TLS Notary is still a very early project. I mean, I don't know how to express that. It's very early in its development. So right now there are no public TLS notaries running anywhere. I envision a future where there will be several notaries running, and because the notaries are completely generic, they don't need to be, they are like public goods. Okay, they can be run by anyone, and they can be used to notarize anything. Okay, they are not application specific or use case specific. They are completely generic. So I envision a future where there are lots of TLS notaries run by reputable, organizations, and you can use them however you like. So in that future, then you can hopefully trust these notaries and not the origin of the data. I don't know if I express myself correctly. I mean, I understand your concern. I mean, you are saying, well, okay, previously we had to trust an Oracle, now we have to trust this other server, notary server. So we are in the same place, but not exactly. I mean, it's a step forward in trustlessness. At least that's how I see it.
Thank you very much. It's very clear, and that makes sense.
Okay. Yeah. Thanks for your question.
I see Mario's hand. Yeah.
Sorry. Yeah, Mario also raised his hand.
Yes, I was. I had the same question about who is running this notary, in fact, and how can we have a trustable notary on one side, and if there were any notaries already available. That's one of the questions I had. So you already answered that. I am thinking we may also have a set of trustless notaries checking each one another to have a trustless TLS notary configuration, maybe in some future. So that's one of the things. The other question I had is that about your flow. From what I understood, Alice sends a request to be using the notary to some web service, Twitter or any other. And okay, and so you receive a JSON with some information.
Correct.
Okay? And then you get that JSON and use that to verify, and you get a JSON which is the proof, and you verify the proof, and it says okay. My question is, if you have verified the proof, you already know that what Alice has sent you, it's okay. You don't if you don't need the data, but just to check that the proof is correct, you don't need to pass the data.
Correct.
And one of the questions is, in the JSON that Alice is sending you or Bob, is there any information that contains the query he made or to the endpoint he made it or something like that? So you don't need to pass the data just to have that type of information.
Okay. If you only need to verify that the data is valid, then you just don't parse anything. You just verify that the return is valid and doesn't return an error.
Mm-hmm.
That's it. Okay.
Okay.
But if you care about the content of the data, then you can, parse it. And like, for example, here, and here is this is the request that was sent to Twitter. Okay.
Mm-hmm.
This is the request, and there's something I didn't mention, and you can redact some of the data that is in the notary. For example, here, these X's that you see here are actually the original token that was used to interact with the Twitter API, and it was redacted for privacy purposes. So TLS Notary allows to do that also. I forgot to mention that.
And you also have, aside from the request, you also have the response, and in the response you also have the data from the response, the data. Okay. So in that JSON that Alice is sending and has been checked by the TLS notary, and you are sending to Bob, you mostly have all the request and all the data.
Correct. It's coded.
So if that's enough for you, you don't need to do any parsing.
The problem is that look, this is how the actual proof looks like.
Mm-hmm.
It's gibberish. I mean, it's only numbers, right? You cannot interpret this without the verifier code. I mean, yeah. So if Alice sends you this and you don't have a way to interpret this, then it doesn't mean anything. You need the verifier part to make sense of all this.
That is the JSON that Alice sends to you.
Correct. That's the JSON that Alice sends to Bob.
So it doesn't have the request and the response.
Yeah, it has the request and the response, but it's codified inside this numbers. Okay.
You cannot understand what's included there. So exactly. You need to parse the data. Okay.
You need to use this function here.
Yeah.
A verify function that takes that data and returns basically this, which is readable.
Okay, but then you don't need to parse that.
Actually, here I'm doing both things. I'm verifying and then I'm parsing. If I take this out, if I don't parse anything, and I just log out the result, the raw result, then look how it looks like. It's plain text, you see, and it's not that easy to parse, to interpret.
Yeah,
that's why I created the parser to make this way easier to work with.
Yes, no. I need to explain why I was asking that. Is that if I want to have a general place where I use the what you have done, and I will have to write a specific parser for each of the sources which I am testing, or for where I needed to prove, and that involves creating a parser for each of the sources. So it's not quite easy to generalize it for any, for example, web request or
Mhm.
okay.
Yeah, you're completely right, Mario. You're completely right. So the verifier is generic. The output doesn't depend on what the origin source of the data is.
Okay.
But the parser is needed in order to make sense of that. For example, here I have the source for the Twitter parser. So here is the actual code that decodes the raw text data and returns the. I mean, this code here is the one who interprets the. Sorry, I lost the terminal.
But that parse you are using is, I think, is more generic than Twitter. It can be used to any web request or no?
More or less. I mean, if I, for example, right now I only develop the Twitter one, but if, for example, I were to develop that Reddit, the one for Reddit, most of this code will be the same. I will have to modify very little of this code, and the same applies to Facebook and to any other source. It's not exactly the same code, but very similar.
It's very similar. Okay. Yes.
Yeah. Mm-hmm.
Thank you. Thank you very much. I will contact you because I have an idea of using that in the social cap proofs, so we can have a field which in the submission form, which is a proof. So if someone can use the notary to prove, for example, that they have delivered a certain number of commits per day or some other thing, I am thinking about how I can integrate proofs into the system in a no-code way. So that's the idea. So, but it's quite interesting what you have done. Okay.
So, sounds interesting. Yeah, let's talk offline. Yeah.
Thank you very much. Bye.
Yeah, you're welcome.
Yeah,
okay.
Hello. This is the final session, but like maybe the most interactive one. So really, congratulations everyone. I love the questions.
Yeah, me too.
All right. Again, Rafael, as we know you like for a while, you're great, but keep this amazing work, man. It's really
thanks.
Heavy. Yeah.
Thanks.
And one last addition is Michael or Mikhail, I don't know, like I think Michael, if I'm spelling it right. He solved the issue, so you want to give the demo again with the fix?
Yes.
Why not?
Can you hear me?
Yes, but again, can you make it a bit louder?
Okay. Is it better now?
Not yet. Yeah.
Okay. 1 second. How about now?
Yeah, it's better right now.
Okay. Great. Okay, so let me share my screen and pick up where it broke. So I was presenting a plugin that allows to register with locking an Ethereum NFT into a configured Ethereum contract. So you configure your plugin on your server to use this Ethereum contract, and then whenever an NFT is locked into this contract, the server adds a commitment behind this lock that goes with this lock, and build a Merkle tree, and then you can prove that you have a witness to your commitment. So you register with NFT and you log in with your secret. So the problem was that accidentally I've deleted a flag switch that would tell my UI that the prover is already compiled. So I have fixed that, and now we are at the moment where it broke. Right now, it freezes because it is generating the proof. Not sure why, but sometimes it takes just a moment, and sometimes it takes longer. So the proof was generated, and this is the data that we will be submitting to the server. So as before, it's just a Merkle root and the proof. And now we can get authenticated. Oh yeah, so we got the token, and we can access the protected endpoint. So this demo is basically divided into some steps. Normally, in a normal web app, it will be more streamlined. This is done on purpose to show the steps that the system is doing behind the curtain. And as I said, the plugins, they have to support the revocation of their output, because things may change. So for example, if someone else, or in this case the same person, altered the Merkle tree by, for example, locking another token with another commitment, our previous authentication should get invalidated. Oh, well, why did they submit it? Oh well, this is I have maybe I clicked something wrong. Well, I'm really surprised by this, because just a moment ago I did just the same, and it worked. So maybe I was stressing and done something wrong, but what we would expect is this we should not be able to refresh the authentication, because the Merkle root was changed, and we would not be able to get the resource anymore unless we regenerate and resubmit the proof. So I haven't mentioned this, but Mina is basically for this big feature is the first the simplicity of using it. So you have your simple usual Express.js, and you can add it as simple as just configuring the plugin server, and then on your login you add Passport.js strategy, the Mina strategy, and you then can protect your endpoints with JWT strategy from Passport. So it's quite easy to incorporate in existing Web2 resources, and you can let me show, and you can support more plugins very easily. So here you can see three plugins that were used, and you configure them in one file, and you get all these new methods of authentication with zero knowledge proofs. So I think this one, like along the way during the development of new stuff, it will be quite valuable to be able to so quickly use like any kind of zero knowledge proof as a source for like authentication authorization in your to your Web2 resources. Okay. Thank you.
All right. Thanks. Thanks a lot. Then this was the last session and the presentation of the Cohort 2 program. So thanks a lot again to builders, mentors, and electors. And really, you put the time, and I'm very excited for the future of Mina. We are all building it together. Yeah. See you guys. Bye-bye.
See you.
See you guys. Bye.
Bye bye.